Good morning, everyone. I'm Rosaria Aloia, a second-year PhD student at the University of Teramo. My project involves the microplastics contamination in food, especially the animal origin food. Today I will share with you my project aims and preliminary results, taking a step back to understand why microplastics content could be a problem and what I am doing to address it. Plastic pollution is a well-known problem that we all of us have heard on the news or social network. How many of us saw when walking on a street a plastic bottle on the floor? I think a lot of us. And plastic pollution is as I said, is a widespread problem, and most of the time when a plastic material reached the end of his life is discarded, not in the correct way, and so it accumulates in the environment. What happens is that plastic go under degradation because we know that the plastic is an eternal material, but it's not like that. Plastic goes under degradation, and UV rays and the mechanical movement of the waves break down plastic and generate microplastics. Microplastics are small particles of different color and size, and can have dimension between 0.1 micron and 5 millimeters. Just to give you an idea, think about that the width of a human hair is on average 50 microns, so we are talking about particular really small dimension. As I said, microplastic pollution, as plastic pollution, is a real problem, and the microplastics reach the most remote places on Earth. We found the microplastics on the bottom of the ocean, in the Mariana Trench, as well as the Mount Everest. In 2022, a research group for the University of Netherlands found in the 80% of the volunteers of the study the microplastics in blood. And but how we enter in contact with microplastics the most? Well, microplastics are in the air, soil and water, so in any compartment of the environment. And we can possibly think that anything that enters in contact with the environment can be contaminated. As the main source of contact for humans, we have food. We know that the food that we ingest every day is an important source of nutrients, but also can be a source of toxic substances if, of course, the food is contaminated, and so microplastics as well. We can think about that if we eat potatoes that were harvested in a field that was contaminated with plastic, potatoes from the soil took microplastics as well. Or if we eat a fish that lived and was collected in a seawater that has a large quantity of plastic, and we know that seawater is the most contaminated on Earth, the fish can have ingest microplastics, and so we found them there. It is known, it was already found microplastic in tap water, in milk, in the seafood and in salt, but very low data are available on microplastics contamination in this food and also in other food. But what we know about the risk for human health? Well, there are some studies about fish and invertebrates where microplastics were found, and it was found also that they can have a toxic effect on the gastrointestinal and reproductive levels. Also, we know that microplastics can be a vehicle for other well-known pollutants, so they can use them, microplastics, for enter more easily in our body, and can also enhance the toxic effect that we know that they have. My study and my research project took place in this scenario. As I said, my role as a researcher is to study microplastics content in food, and in the case of my research project, I'm dealing with a well-appreciated food, especially in Italy, the common clam. I developed a method for extract microplastics from clam together with the water biology unit of IZS of Teramo, where I do my activities, and the method can extract microplastics and classify them by their shape, color and size, so on a morphological level. Also, I want to study the chemical characteristic of microplastic, so study what the type of polymer they are made of. Develop a method for the common clam was something that we choose for a reason. The clam is a bivalve mollusk, and all bivalve mollusks, given their nature of filter feeding, ingest a large quantity of water. So they are generally used as an indicator of the healthiness of a water body, because they concentrate a large quantity of pollutants, and microplastics are also one of them. Dealing with food when you have to do chemical analysis is not simple. And this is because I had to find on one part the reagent, the correct reagent that can destroy the tissues and all the interferences that can have a problem with the microplastics identification. At the same time, I had to preserve microplastics, so I have to preserve their characteristics. This because if I not preserve the characteristics, the situation I can have is that I collect wrong data, or also I can lose microplastics during the analysis, and this is not what we want to have, of course. What I found in my studies: microplastics, as we expected, were in our clams, and in the half of the clams we found many microplastics, but this is a work in progress. This is a preliminary result because we have to collect from a scientific point of view. To make an assessment, we have to have enough data to make consideration. So we have to analyze more samples. The data that I will collect at the end of my project can have an important role on making a risk assessment. So, to understand if the content found can be a problem for people that consume this appreciated food. Thank you for the attention, and follow me on all the scientific platform and on my social network. Thank you.